So the video for chapter 5, section 12, is in the videos link. Maybe I didn't post it yet. And then if you go to the playlist, see if it's on the playlist. There it is. So in the videos link, if you click the kind of like the menu in the upper left, that'll give you the playlist, and you can just watch them in Blackboard or on YouTube. But here is could see 512. That'll be. Oh yeah. Okay. So 5.1 through 5.4 we did 2 weeks ago. 5.11 we did last time. 5.12 is online, so I know it's kind of scattered all around, but 5.5 through 5.10 is what's left for chapter 5. Okay, cool. So kind of fill in that missing piece tonight. Okay. So then the second thing that's kind of new is if we go to the in-class link, you'll see for the sections there are kind of animations and different kind of interactive, you know, tools and resources that are geared, toward each section. So I thought this might be a kind of neat way to work through the rest of chapter 5. So let's start with section 5.5, the do-while loop. Okay, cool. So let's kind of switch back and forth. Okay, cool. So sorry for my handwriting, but just kind of get the very basics out here. So the do-while loop, kind of boring. Not as common as just the while loop. It starts with the keyword do and statements inside curly braces. If you just have one statement, you can drop the curly braces. After the curly brace closes, then you have the while keyword followed by a condition. So that's a lot like the while loop, but you also have a semicolon right after the closing parentheses for the while condition. And so then just taken all together, this is our syntax for the do while. This is a, what do you think, pre or post test loop? One vote for pre, one vote for post? It's a post test loop, yeah. And what does that mean? Awesome, cool, exactly. The conditions tested after the loop runs. So that means we always get at least how many cycles of the loop? One, yeah, exactly, because the condition's not tested till after the loop runs. And so it runs one time, no matter what, and then the condition's checked, and if it's true, it runs a second time, and then the condition's rechecked, and if it's still true, then it runs a third time, and so on. Try to figure out how to do this. this way. So then over in Blackboard, we can experiment with the logic of the do-while loop. This is a flow chart, and what we can see, I'll put it in full screen. It's kind of small. Is the syntax of the loop up here, so do and then some curly braces and then the while keyword. The condition in parentheses here, it's called the loop continuation condition. You can just call it the condition, we're just, it's the same thing. And the semicolon, don't forget the semicolon at the end. If you click the B, then that'll start up kind of an animation. And this animation is going to show us that the do-while loop executes the body of the loop first, and then the condition's checked. And if the condition's true, then the loop continues. So I'll just click Start Animation, and you can follow along on your screens. Does everyone see this? And can you pull it up okay? Working? Okay, cool, awesome. Nice. So this do-while loop, it's setting count to 0. That's not really part of the loop, but just kind of a condition before it happens. And then now that count is 0, we've got these do-while statements. The condition is what? Count is less than 3. Awesome. And as long as count's less than 3, or if it's the first time the loop runs, then what'll get printed out? Yeah, welcome to C++, next line. Yeah, awesome. That's cool. And then what happens to count? Incremented. Yeah, cool. Awesome. Cool. So we've got count being initialized to 0. And then the loop body's executed. That would have happened whether or not count was less than 3, but count does happen to be less than 3. So welcome to C++ is printed that first time. Counts increase from 0 to 1. Count's now 1, and then the test is whether 1 is less than 3. Here's that post test. Since that's true, then the loop body's going to get executed. So here we go. Count's 1. We print out welcome to C++ and increment count to 2. And count's now 2. And so it's time to test if 2 is less than 3. Yes, it is. So we'll run the loop one more time, at least. Printing out welcome to C++, then this is the body again of the loop. And then incrementing count now from 1 to 2. Or I'm sorry, it was already 2, from 2 to 3. So then count is 3, and I think it was that the third time we printed out welcome to C++. So it's post-test loop, so then 3 is checked to see whether it's less than 3. That is obviously false, so the loop finishes. Okay. So how many times did we end up printing out welcome to C++? 4 times? Close, maybe. 3 times, yeah, cool, nice, nice, okay, cool, nice, yeah. Once when count was 0, but that would have happened anyway, once when count was 1, and once when count was 2. Oh, actually, that would also lead to 3 welcome to C++ lines getting printed out, yeah, if we had plus plus count. And actually, the trick that I like to use is count plus plus and plus plus count. Those are the same unless they're part of a bigger expression. So if it was like x equals count plus plus, then that'd be different from x equals plus plus count. But just by themselves, yeah, the plus plus something or the something plus plus are always the same. Any other questions? Okay, cool. Well, then let's go ahead and move on. So section 5.6, I know that felt kind of fast, so maybe, um, maybe later we can do another example or something. Uh, but let's move on for now to the for loop. Yeah, and the for loop is pretty straightforward. It's kind of maybe it simplifies things a lot of the time. Uh, the for loop has three parts. The parts are known as arguments, and the three arguments to the for loop are the initialization, which is right here, I equals initial value. The test, I is less than n value. And the update statement, I++. And then in curly braces is the body of the loop. If you only have one statement, again, you can drop the curly braces. That's true for all three loops. So assuming that loop body on the left and loop body on the right are the same, do you think that this for loop and this while loop are equivalent? Yeah, they are. Yeah, Yeah, so that's a cool thing is that any of these three loops, for, while, and do while, can actually be rewritten in terms of each other. Yeah. So yes, these are the same. Just the initialization happens, in a different place. The conditions kind of in the same place. It's the argument to the while loop, and then the update statements, at the end. This confuses a lot of people, but the update statement is still the last thing to run in the loop. So I gets initialized to initial value, and it's a pretest loop. So I is checked to see whether it's less than n value. And then the loop body runs, and then this last thing happens, I gets incremented by 1. So that confuses some people for the first time because they, you see them all next to each other and you think they happen, one then the other then the next. But really the first one and the second one happen, then the loop body happens, and then the update statement. So part B just has the for loop by itself. Any questions about the syntax? Oh, good question. No, only the first two arguments have semicolons at the end. The last one, it just is followed by the parentheses. Yeah, totally arbitrary. It could have been any other way. And you'd think, yeah, I++, since that's a statement, should have a semicolon, but for some reason, yeah, it doesn't. Yeah. So let's check out a flowchart of the for loop. Hey, welcome. Oh, yeah. Sorry. So the first thing that happens is the initialization statement, which here is being called initial action. Oops. And that might be true or false. Or I'm sorry. First, the initial action happens, and then the condition's checked, and the condition might be true or false. So that's this here. By the way, in these flowcharts, the processes are rectangles. The start is like an empty circle. The end is an empty circle, and usually it's a little thicker. And then the flow is indicated by the arrows, the directions of the arrows, like the sequence of processes. And then the decisions, yes, no decisions, are indicated by diamonds. So the loop continuation condition, it's like a yes, no decision, meaning it could be true or false. If it's false, then nothing happens. The loop is just kind of ignored, right? If it's true, then the statements of the loop body run. And action after each iteration. So after the statements in the loop body run, then the loop continuation condition is checked, yet again. And it might still be true, in which case the loop will keep running, or it might have become false, in which case we'll exit the loop. So let's take a look at a concrete example with this animation in part B. So we can reset the 3 to be anything, but let's say that we wanted welcome to C++ to print out 3 times. Well, if the for loop up here runs, then what'll happen is I will start by getting set to 0. It's a pretest loop, so I'll get tested to see whether it's less than 3. And then if it is, this loop will run. And after the loop runs, then I will get incremented by 1. So here we're just seeing those kind of replace the parts of the previous flowchart. And if we start the animation, we could see the initialization statement sets I to 0. It's a pretest loop, so I is checked to see whether it's less than 3. Yes, 0 is less than 3. So the loop body statements will be executed. That means welcome to C++ is going to get printed out with the new line. And then, remember, go back to the update statement. So then I gets incremented by 1. I is now 1, and 1's less than 3, so the loop body will be executed another time. So then we'll see welcome to C++ the second time. And I'll then get incremented to, what is it at? It's at 1, so to 2. And 2 is less than 3, so yeah, we'll run the loop again, printing out welcome to C++ in a new line. And then we'll increment the 2 now to 3. Check the condition again, but 3 is not less than 3. So that statement's false, so we'll just exit the loop. Did anyone set theirs to something other than 3? Okay, cool. Okay. So we have kind of a lot going on, don't we? I'm going to move down. I don't know. Tell me, I could do it. We could try to do it here, or we could try to do it in Visual Studio. Let's try it here and see. So is this a good idea, or maybe I should save this? Yeah, maybe we should just do it in Visual Studio. Yeah, because I think we would have to refresh it to get back the old stuff. Is it cool? Okay, good. I'm glad. Okay, nice. Good. Yeah, I think just versus a textbook alone, yeah, it kind of adds a lot. Yeah. Awesome. Nice. I'm glad you think that is cool. Yeah, I think so too. We'll just make a new project called uh, loop examples. Add a new item to source files. We could call it loop examples again, or really anything. So then, and I'll do the easy part, which is just kind of filling in the skeleton of a simple program. And let's come up with a loop that will print out the numbers from 1 to 100, 100 to 1, 20 to 2 in increments of negative, well, going down by 2, so counting down by 2s from 20 to 2. One loop that'll print out 2, 5, 8, 11, 14, 17, 20. And one loop that'll print out 99, 88, 77, 66, 55, 44, 33, 22, 11, and 0. And let's use for loops for these. So who can think of a for loop that will print out the numbers from 1 to 100? Yeah, awesome, cool, right, good call, Like this? Cool, good call, good call. Awesome, good call with the less than or equals to as well, cool. Increments, awesome, cool. Okay, sounds good, so I plus plus to get increments of 1 each time. Okay, and then now this part is not too bad. Yeah, what should we do in the body of the loop? Yeah, let's just see out I. Good call. Something like that. Yeah, or maybe should we do them on the same line with commas or something, or should we do, or just spaces maybe? This cool. Okay, separate lines. Okay, cool. What about 100 down to 1? Oh, this first one? Oh, okay. So maybe. Oh, okay. Oh, okay. Cool. That's what I was thinking too. Yeah, we could put a space instead of the end line. Yeah. Either way. Either way. Oh yeah, I kind of stuck it in mind. Let's do the spaces though. That way maybe we can see them a little more clearly, so we don't have to scroll so much. So what about 100 to 1 now? Okay, cool. The same. So what's our initialization? Good call. It's cool. Initialize I to 100. Yeah. And then our condition is going to be less than or equal to? Yeah, more than or equal to. Awesome. Yeah. More than or equal to what? 1? Yeah, cool. Good call. Awesome. Yeah. And then I for update decrement. Cool. Minus minus. Nice. Cool. And then is the body of the loop going to be the same? Okay. Yeah. All right, let's kick it up a notch. So, or take it down a notch maybe. So how about 20 to 2 down by 2s? Yeah, uh-huh. Good call. Okay. Greater than? Greater than or equal to 2. Awesome. Cool. Sounds good. Nice. I, yeah. Uh-huh. Good call. Uh-huh. We want I to go down by 2 each time, so I minus equals 2. Cool. Or I equals I minus 2. Yeah, awesome. Cool. So either of those you could put for the update condition. Let's go with I minus equals 2. And then is the body of the loop going to stay the same? Yeah. Okay. Now, here's a tricky one. How about 2, 5, 8, 11, 14, 17, 20? Okay, cool, awesome. So that sounds like which section? The last one. Cool. Okay. Uh-huh. Looks like we're going up by increments of 3, so I plus equals 3. Awesome. Or I equals I plus 3. Cool. Initialize I to 2, you said? Uh-huh. Sounds good. And our condition. I is less than 20? Less than or equal to 20? Cool. Okay. Sounds good. Oh, whoops. Yep. Good call. Uh-huh. Declare. Yeah. Good call. I think. Yeah. Good call. And then, this is that one. Leaving just one. So, how about this one? 99 to 0. Decrement by 10, you said? By 11? Okay, cool. So over here, we've got our decrement statement. How are we going to decrement by 11? Minus equals 11. Awesome. Cool. Where should we start I? 99. Sounds good. Awesome. Okay. And what about our condition? Awesome. I is greater than or equal to 0. Everyone agree with that? Or any changes? Body's the same? Cool. Okay, awesome. Thanks. The same thing. Okay, let's see. Scout I space. Okay, cool. All right. So let's go ahead and run this and make sure we get, the right answers here. Think of that end line. I should have put an end line at the very end. Minus some formatting. Ugliness, yeah. That's kind of cool. Yeah. Okay. Yeah. Yeah. Oh. Whoa. Yeah. Okay. So the answer is no, we didn't need to do it all 4 times. But if we do it inside uh the arguments of the for loop, then it's a local variable, so it goes away after the for loop ends. But we could, yeah, where would we declare I to not have to keep re-declaring it? Anywhere above it. Good call, uh-huh. So we could go like in I here. Oh, sorry? Oh, okay. Awesome. Yeah, we could even make it a global variable. Cool. Awesome. Let's put it inside the main method, but outside the for loops, and that way we can reuse it in the for loops. But we could also reuse it in the for loops if it was a global variable too. Cool. Yeah. So this is a nice solution, and it kind of reminds us of the fact that the initialization statement really, you don't have to declare your variable in it. You could use a variable that's already in scope. And I suppose we could print out just, a new line before the press any key to return the continue statement, and then let's make sure we get the right numbers. So it looks like we've got our 1 to 100. Let's see, does it go up to 100? This is small. Well, zoom way in on something that's really small. Oh, there. Okay, well, not quite. Still. Okay, well, oh, well. Uh-huh. Oh, okay, cool. Yeah. Where does it end? Oh, okay. Well, oh, okay, okay. Oh, there we go. Oh, okay, cool. Oh, you know what? We didn't put any like new lines or anything between the loops though. So they're kind of all on one line now. It's kind of the opposite problem, the exact problem I want to avoid, but now it's just horizontal instead of vertical. So, okay. Yeah, so who can fix this so that the output's a little more sensible? Okay, cool. Oh, okay, like here, after the for loop, here? Oh, okay. Oh, okay. So either, are you thinking in the for loop or out of in it? Okay. Well, that's fine too, yeah. Um, let's try out after the for loop, and then that would mean we see spaces within each, number sequence, but a new line after. And maybe that's the easiest way to format it, but really it doesn't matter. Yeah, anyway, it's fine. Okay, cool. Yeah, so and that was a good call, both you guys adding a C out end line to um, kind of break up the long list. Here, what do we have? Okay. Looks like the first one goes from 1 to 100, so that's kind of cool. The second one goes from 100 to 1, so that's kind of cool. The third one looks like we go from 20 to 2 down by 2, and then from 2 to 20 up by 3s, and then from 99 to 0 down by 11s. So that looks right. Maybe making it small was not a good idea. Okay, any questions or follow-ups about that? It's kind of wrapped around now. So I think we're here now, which is 5.7, uh, keeping a running total. And this we kind of know from before, so I think if we uh, working on this exercise, we'll reorder the statements or just the lines actually to uh, have the program or this portion of it print out the sum of the first 100 positive whole numbers. And maybe we can get a volunteer too to walk us through. Yeah. How are you going to reorder it? Okay, cool. Move this up. Okay. Uh-huh. Then the while. Okay. Sounds good. Beginning curly bracket. Cool. Sounds good. Awesome. Huh. Which one? See how? Cool. Awesome. Okay. Okay. That's it. Everyone agree with that? Oh, okay. So which line? This one or this one? Oh, this one. Okay. Well, let's think about it. So, how many times do we want to print out the sum? And just once. Cool. And when do we want to print it out? At the end, yeah, after all the numbers have been summed up. Yeah, cool. Awesome. So let's move this line down here. Cool. We get some positive feedback. Okay, cool. Okay. Yeah, this is on Blackboard. Yeah, Thanks. Yeah, cool. Yeah, yeah, it's awesome, I think. Yeah, totally, totally. Yeah. So any questions about that? And uh, our book mentions that sum has a special name, which really no one, I don't think, uses. But do you remember what that kind of variable is called that keeps a running total? Accumulator. Yeah. Exactly. Yeah. Cool. Awesome. So sum is an accumulator variable. So then, if you don't mind, let's go ahead and spend a few minutes working on this checkpoint. And it's the question is with the input of 23450, what's the output of the following code? Yeah, yeah. Okay, cool, awesome, cool. And can you walk us through? Do you want to um, give us some details on that? Nice. Nice. Cool. Uh-huh. Yeah. Nice. Uh-huh. Cool. Awesome. Yeah. Yeah. Uh-huh. Yeah. Awesome. Cool. Okay, let's hear it for Jack. Okay. Awesome. Cool. And that is the right answer, and that's a great explanation of that. Any follow-ups or questions? Okay, cool. There's nothing particularly new in this next section either. 5.8 Sentinel values. So Sentinel, just well, does anyone know what that means? Like, if just as a just in maybe old usage, I don't know if anyone still uses it. Guardian, yeah, cool, yeah, exactly, Oh, okay, cool, yeah, that's all I know about that. Yeah, Sentinels, yeah, like a guardian, kind of on the lookout. And so a sentinel value is one that's looking out for a special condition. That condition is one that'll signify the end of input. Could be from a file, but it could also be from the keyboard. For example, if we were entering in a bunch of soccer scores, and we wanted to have a way of allowing any number of soccer scores, but also to stop the entering process at some point, so that maybe we can find the average or do something, the next thing. Then, and so we're not in an infinite loop. Then we could have a sentinel value, maybe -1. And so if the user types in -1, no matter when they type it in, that'll signify the end of the input. Here's a program that uses sentinel values, and we can do kind of a walkthrough where it's animated. So as we know, the main function is the first to run in the program. And the first thing that happens in the main function is this prompt to enter an integer, but that the input ends if it's 0. So is our sentinel value -1 here? Or? Yeah, it looks like it's going to be something else. Okay, cool. 0, yeah, cool. Nice. And so here in lines 8 and 9, we're declaring and reading in this variable data, so value for it. And we can put in the numbers as well. So let's put in something, just anything other than 0. So feel free to just put in anything other than 0. 15 or 1? Okay, cool. Okay, cool. So here we're seeing a floating 15 getting, stored to memory. When it gets stored as 1.5, it gets stored in the binary representation in 4 bytes. And the variable name is data. So that's going to, refer to those bytes in memory. Here's a floating 0, which is the initial value of sum. So now we can see in memory there's 4 bytes carved out for, we can't see that there are 4 bytes, but there would be 4 bytes carved out for this value 0, another int. Because sum is initialized to 0 when it's declared in line 12. And now we've got our loop continuation conditions. So the while loop, the conditions that the input value is not equal to the sentinel value. And that makes sense, right? Because we want to run the loop as long as they don't put in the sentinel value. Or in other words, once they put in the sentinel value, we want to stop running the loop. Which line will be executed after this one? Line 13. 15, vote for 15? Okay, cool, awesome. I guess that's kind of a coincidence. And then, does anyone disagree with that? Vote for 15? Okay, cool, it's just out. Awesome, nice job. And 15 is then added to sum, which was 0, so now it's 15. Inside the loop, then we're kind of reprompted, enter an integer at the input ends if it's 0. And here's the output, by the way, down here. That's small, but you get the idea. And then we would put in the next integer. What do we want to put in for it? Okay, 1. Cool. Okay, awesome. Nice. And then we can see 1 is now the value of data. Anyone want to predict what happens next? Which line runs? Cool. Okay. Yeah. Yeah. I guess the while condition's checked. And is it true? Data is not equal to 0. Yeah, it's true. Awesome. And so then, will we go back to line, which line? 15. Cool. Awesome. Nice. Okay. 1 is added to sum, changing its value from 15 to 16. And then we get reprompted. Have we seen enough, or is that enough, or try another? Okay, cool. Okay, cool. So then let's just enter 0, that sentinel value. Okay, cool. Okay. Then we can see data goes to 0. The while conditions checked again. And what will happen after this check, once they evaluate? Oh. Line 25. Okay, so I thought it would be line 15. Why is it not line 20? Why is it not line 15? Oh, because the condition's false. Awesome, cool. So we'll exit the loop, and that means we'll go to the first statement outside the loop. So not 25, but really which one? 23. Cool. Cool. But that's the exact right idea. Yeah, because the condition's false, we're gonna exit the loop. Okay. Awesome. And then here's our output. We see the sum is 16 coming from line 23. And then the return 0 exits the main function and ends the program. Okay, so any questions about that? So if you wanted to, down here, you can fill in the code. It's the same program, but like line 9 is missing. So then you could just fill in the program. It's not extremely useful because we just saw the full program and walked through it. But there maybe we can try some of these where it's just this part. Okay, cool. But a cool thing about this these tools is that you can compile right here. So now with the modified code, we can hit compile run. And let's see, we're seeing the program run, and the input goes right here. So the input's 1 space, or 1, and then space 2, space 3, space 4, space 5, space 6, space 9, space 0. So you could change that around, and maybe we just wanted to see what would happen if we only put in 1, 2, and 0, and then ran it again. Well, that sentinel value ends the loop after, it's entered, which now comes a little earlier. Okay. So, any experiments that anyone wants to do with this, or anything like that? Questions? Negative numbers. Okay, cool. So maybe like for which, yeah, for -2. Okay, cool. Okay, what do you expect will happen? Okay, interesting. The sum is -1. Okay, cool. So it sounds like only 0 will stop it, and the -2 will just get read in as a negative number. Awesome. And that looks exactly right. This sum is -1. Awesome. That's a great test case. Oh, here, yeah, good call. Yeah, so if we change well data is not equal to 0 to less than or equal to 0, yeah, then it's kind of like any 0 or negative number will be our, kind of our sentinel values there. Okay. So then if we ran it again, yeah. Cool. We'd probably, yeah, good call. Sum is 1. How come, Daniel? Cool. Okay, let's see. Yeah, okay. Oh, the sum is 0. Interesting. So we entered 1, and the sum is 0. So it looks like it's not 1. Okay. Okay. I think it shouldn't be well data is less than or equal to 0. It should actually be well data is, if we want to test out Daniel's idea of making all the right negative sentinels, yeah, then really we only want to do this stuff if it's not a sentinel. So maybe just greater than 0. Cool. Yeah. And then we see that -2 stopped things before the 0. Now the 0 is just like out there. It's not even part of it. Yeah. It was never read in, right? Okay. So any follow-ups? Those are great. I love those test cases. So any questions or anything before we move on? So um, maybe it makes sense. Sorry, I know, Jack, you're just getting back, to take a little break here, just a short break, and then pick up with 5.9 and then round things out with 5.10. So unless there's any strong objections, let's just take a 10-minute break. And feel free to grab some Starburst or oh, someone ate all them. Yeah, they always eat all the pink ones. And never do orange. This is still recording.